Today, we will be doing acid bases day 3. Here we go. Aim. How do we use table M to determine acid and base indicators and also table J? Here is the do now question. Hit pause on your iPad and complete the 2 do now questions given. Okay, we're back. So let's look at the first question over here. The Bronsted-Lowry base for the forward reaction is, again, we learned the forward reaction is going to the right. That's your forward. Reverse reaction is going to the left. Reverse. Okay. Now this is a double arrow here. So when you do these problems here, all you have to do is this. Connect the compounds that look similar. The only difference is always one hydrogen. So H2O on the left looks like which compound on the right? Yes, H3O plus. The only difference is this has 2 H's while this has 3 H's. So let's connect these, and that's going to be our pair. Now, we learned in Bronsted-Lowry acids, the acid is a substance that has one more H. Well, this has 3 H's, this has 2. The one that has one more is our acid. Now look at the pair. The one that has one less is going to be our base. Now, you can never have 2 acids or 2 bases on the same side. So if this is a base, this must be an acid. If this is an acid, this must be a base. To prove it to you, if I connect, let's use a different color here. If I connect this pair, HCl with Cl negative, this has 1 H, this has 0. The one that has one more, again, is your acid. The one that has one less is our base. So this question says the Bronsted-Lowry base for the forward reaction. So very simple. We said forward goes to the right. Now, the answer is going to be where you start. So where do we start the reaction? Well, if we're going to the right, we start from the left side. So the base on the left side is this guy right here, water. So water is our base. Okay. Let's look at the second question here. What are the 2 Bronsted-Lowry acids? So what do we say? To determine that, we must connect the 2 pairs. HSO4 looks like SO4 negative 2. The difference is this has 1 H, this has 0 H's. Again, the one that has one more hydrogen is your, you should know now, this is your acid. This must be your base, the one that has one less. Again, if this is an acid, this must be a base. If this is a base, this must be an acid. Now remember, we said acids donate the proton, base accepts on the same side. Acid donates, base accepts. Acid donates, base accepts. Acid donates the proton, or H plus, base accepts. So it says, what are the 2 Bronsted-Lowry acids? Well, the Bronsted-Lowry acids are HSO4 and NH4 positive. So where do we see that as an answer? Yes, choice 4. Good. Let's move on to today's work. Okay, this is just an indicator thing. You can look on your own time. Here we go. Here's reference table M, a new table we're going to learn. So these are our 6 indicators. What is an indicator? An indicator is a substance that helps you determine whether or not it's an acid or a base, right? Because acids and bases are dangerous. We don't want to go around tasting or touching them. So one way is to simply dip them into an indicator, and when the indicator changes color, it will determine whether it's an acid or a base. All right, so over here I have the approximate pH color range. I have 3.1 to 4.4, 6.0, 7.6, so on and so forth, all the way down to here. These are 6 indicators. Then these are the color changes here, red to yellow, yellow to blue, yada, yada. Okay, very simple. Acids are on the left, bases are on the right. Acids are on the left, bases are on the right. So, what does this mean? Well, let's look at the first indicator given to us, methyl orange. So if I dip an acid into methyl orange, and if my pH number, see how it says pH, is less than this number, 3.1 and less, all the way down to basically, like 1, it will turn this color, red. If my indicator, if I dip a substance and the pH, right, is, let's just say 7.0. Well, I know if I'm using methyl orange, 4.4 and higher, all the way up to 14, right? Because remember, the pH scale goes from 1 to 14. 7 is neutral. We'll get into that later on. If this number is above 4.4, it will turn yellow. Okay? Same thing over here, bromethymol blue. A bromethymol blue, if I dip something into it and the pH is under 6, what color will it be? That's right. The left side will go with the left side color. So if I have pH of 5.2, you know it's going to be under 6, it'll be yellow. If the pH is 11, that's above 7.6, that will be blue. So on and so forth. Let's do one more. Phenolphthalein. Phenolphthalein is another one here. Again, if my pH is under 8, it will turn colorless. If my pH is above 9, it will turn what color? That's right, pink. And so on and so forth as you go down. Under 4.5 for litmus, it will turn red. Above 8.3, it will turn blue. Don't worry about the numbers in between. They never ask questions on that. Okay. Bromcresol grew. Under 3.8, it's yellow. I'm sorry, bromcresol green. If it's above 5.4, it will turn blue. Thymol blue, below 8, yellow. Above 9.6 is blue. Okay. So let's move on here. Let's look at these questions here. It says, match the color of the indicator to table M, either by pH value or by the color change that end up in the reaction. Phenolphthalein is pink. Pink. Aqueous solution having a pH of, well, there's 4 choices here. 2, 5, 7, 12. Well, let's see. Let's go back to table M. Phenolphthalein is pink when it's what number, we said? The right side numbers are the bases. Right side colors go with the right side numbers. So we said, if our pH for a phenolphthalein is above 9, it will turn, the right side goes to the right side. It will turn pink. So the question said, in which solution will the pH of phenolphthalein turn pink? Well, pink is anything above 9. So let's go back to the question. So now, pH is pink. The phenolphthalein is pink here. Phenolphthalein is pink, we said. Having a pH above 9. Well, who's above 9 here? That's right. Number 4, 12 is, because anything above 9 is a base. That will make it turn pink. Good. What is the color of indicator thymol blue that has a pH of 11? Okay. Let's go back to thymol blue. It says pH of 11. Okay. So let's go to thymol blue. Here's thymol blue down here. Thymol blue, if it's 11, is going to be not under 8. It's going to be what? Yes, above 9.6. So above 9.6, right? Isn't above 9.6, isn't 11 above 9.6? Yes, it is. That will make it this color, blue. So our answer will be blue, okay? So let's go back here. So that will be blue. Oh, sorry. Here we go. That'll be blue. Last one. If the solution of methyl orange is added and the color changed from yellow to red, which compound is it? Okay. Well, it changed from yellow to red. So we don't care about yellow. We care about what color it changes to. It changed to what color here? Red. So if methyl orange turns red, what color is it? Well, let's go back. We know that methyl orange turns red when its pH is below 3.1, okay? Make it an acid, right? Remember we said before, anything below 7 is an acid. Anything above 7 is a base. 7 is neutral. So we need to see which of these is an acid here. Well, then you would have to go back to table K. On table K, there are a list of acids there. Take a moment right now, go to table K, and look to see which of these compounds is an acid. So pause the video. Yes. So now, the acid here, well, this is CHO, CHO. CHO is a non-electrolyte. This is a metal with the OH. That's a base. No good. We're looking for the acid. CHO, CHO. CHO is no good. It's not an acid or a base. Remember this guy we said on day one? This is called CHQ. CHQ on day one is acetic acid. So all you got to do, guys, is notice that when it turns from yellow to red, you look at the second color, turn red. On table M, red is an acid because it's below 7. It's actually 3.1 and lower, so it's actually a strong acid. And the only acid of the 4 choices is CHQ. Okay, I know, funny name. CHQ. Here we go. Next, table J. Table J says activity series. So basically, the most active metals are at the top, the least active metals in the bottom. Well, if you notice, copper, silver, and gold are at the bottom. Why? Because they have low reactivity. Silver and gold are silver is used in silverware, it's used in jewelry, gold is used in jewelry and other high-tech electronics. Copper is used in pipes and electricity and everything else. Why? Because it doesn't degrade quickly. But there's a guy over here that's strange. He's not a metal. See how it says metals here? There's a metal here that there's an element here that's not a metal, but yet it's on the metal side. That's right, H2. H2 is a non-metal. It's not there, though. A non-metal, why is it on the metal side? Well, we learned in day one that whenever you combine an acid with a metal, you're going to produce hydrogen gas. So this guy is the acid. So basically what this table says is very simple. Anything that's above H2 will react with the acid. Anything below will not react. Not will. Okay? Don't worry about these guys here for now. We don't care about those. Okay. Let's move on. Here's a little demonstration. We'll get that later on. Doesn't matter. You're watching your own time. Here you go. So I basically wrote it out for you here, guys. All right? Here's H2 on table J. Everything above H2 reacts with an acid. So anything above reacts. Anything below does not react. Again, non-metals, we don't care. So which element reacts with HCl? Well, let's go back to our table. We said HCl, is that an acid or a base, first of all? Well, what is... Oh, yikes. Come on. Sorry. Okay. HCl. What do we know about all acids? All acids start with an H except for CHQ, right? Again, if you don't know if it's an acid or a base, go to table K and L. Since it's asking for HCl, HCl is on table K. Use your tables, people. Look it up right now with me. HCl, because the H in front is an acid except for water. So this is an acid. Acids react with anything above H2. Well, let's see. Well, we have our choices here. Cu, does Cu react? Well, where's Cu? Cu is below. Anything below does not react. Cu is no good. Ag, well, Ag is also below. No good. Au, funny guy. No. Au is below. That's gold. That doesn't react. The only element that's above here, which is near the top, is potassium on table K. I'm sorry, table J. That does react. Okay, let's prove it to you. Let's go back to table J. Where's potassium here, guys? Here's H2, here's the acid. There's potassium, a very reactive metal. Any questions? Good. If you have a question, hit me on Remind. Thank you. Have a good day.